Hello, hello. So this is a brief overview into what I did with my students to kind of get a feel for it. So we did a discovery activity over special right triangles, and we used Nearpod, GeoGebra, and HP Reveal to help us with our process. So the first thing students did is they logged into their Nearpod accounts. This is a program my school has just recently launched and really dove into at the high school level. And so students have become accustomed to this and become used to using this to help with their lessons. There are live lessons where I can control the pace, or student pace, where, as it sounds, students can control how fast or slow they go through material. For this discovery activity, I chose student pace to provide a little bit of differentiation. So students who could go through it faster were able to do so, and students who may needed to reflect more could also do so. So they went into this. I'll make it full screen just so we can see a little bit better. We have our special right triangles. They went through that. The next page explains our lesson goals, what they're planning, their standards, our learning targets, and success criteria, so they know when they're going to be successful within this entire unit. And in that success criteria, it says special right triangle characteristics, which is exactly what they are discovering during this lesson. So this explains the discovery activity, what they're planning to do. They're going to go through different modules that will help them search through and figure out what these relationships are. I listed the 5 modules, and I'm allowing them to go through this at their own pace or use as many as necessary until they find out what that relationship is. So the great thing about Nearpod is I can embed GeoGebra directly in to the Nearpod, so they don't even have to leave Nearpod to access and use GeoGebra. So this, you can see there's a lot going on this page, which is why I specified these first 5 for them to use. So they just click on one of these special right triangles. It walks them through it at the front, at the top, as to what to do. You can move these little white points around, and this slide me allows them to create a triangle. And it walks them through the process of that triangle being created. And as they scroll down, they can see some questions that kind of guide them through a process and trying to think through, okay, what could this be? Do you notice any patterns? So it's talking them through the patterns. If that one didn't help, they can easily go to another right triangle and see it again in a different format. So this is a different right here. Same triangle, but just shown a little bit differently. And then once again, it walks you through finding the angle. And so you can find the angle. So this discovery activity would help them see, hey, that's 45 degrees. And that will help them answer these questions using Pythagorean theorem. That's a huge prior knowledge for them to know. And they will just go through all of these until they have a grasp on what they think the rules are for the 2 special right triangles, 30, 60, 90, and 45, 45. Once they feel like they have grasped this concept and they are confident in the pattern, they will continue on with the Nearpod. It says, now you're going to show what you know. Click on the next slide to share your thoughts with the class. And this page will be shown to the entire class. So once this loads, students are able to comment and add what have you discovered about 45 and 30, 60, 90 triangles. They can add any of their thoughts, and it's going to come up here almost like a pin board for other students to talk about. So once everyone has entered their thoughts to the pin board, we will come and have a brief debriefing as a class to see if we can see anything in common. After that, that is when we will go into some formal-ish notes, looks like this, where we will suppress and show what we have known. What did we notice about these triangles? We'll talk about as a class and fill these notes out as a class. Now, as differentiation, just in case the GeoGebra was overwhelming for some of my students, depending on level, there is a non-technology-based section that you can use. It's the same premise, it's a little bit different, but finding the pattern for these triangles as well. It's just a modified version for them. So once we have done that, Students went, we debriefed, and we talked about it. When students came back the next day, we did an HP reveal where they went around and showed what they knew and explained it to each other, what they have found, and they created little videos of explanation. And then once we were all confident that we understood and knew it, they paired up and they went through this little activity that just practiced some of the relationships with one another. Once they were confident that they understood it and they could answer all of these questions, at the very end, they answered a reflection sheet. So this reflection sheet was for them to think back to what we had discussed and what they discovered the past 2 days. Why are these triangles called special right triangles? What's special about them? How are they similar? How are they different? And how could they be used in a real world application? So that's what we did. This is almost like a very miniature topic within our units, but it's something I do like to spend a few days on, and I want them to have a good grasp on it because it helps with going into trigonometry. So that is just a debrief of what we did in our class. Our big things that we used was the Nearpod and the GeoGebra. Then the HP reveal the next day helped us to solidify and explain to one another through collaboration. So thanks for listening. Let me know if you have any questions.